Hello, we're going to talk about steam engines, and exploding water. Everything we talk about happened in Cornwall, the nearest bit of England to the United States. You'll hear some things that I hope you'll never forget. First is a couple of words about James Watt and his invention of the steam engine. Those two words are, he didn't. He never claimed that he did. He did claim that he had improved the atmospheric engine of Mr. Newcomen. Newcomen's atmospheric engine was known as a fire engine. It was described as lifting water by means of fire. The word steam wasn't used. The fire would boil water. The steam produced was drawn into a cylinder and sealed. That steam was condensed with cold water, leaving a vacuum. Atmospheric pressure forced a piston into the cylinder. The steam did nothing except disappear. Watt improved the thermal efficiency of the engine by making the condensation occur in a separate chamber. He lived in Cornwall for 23 years. With his engineer, William Muiroch, he erected 60 of his engines and retired in 1800 when his patent expired. Watt refused to use what was called strong steam because he was aware it was dangerous. What happened inside boilers was a mystery, and so was seen as the work of the devil. Boilers burst and killed people. This isn't the second thing you'll remember because you already know that water raised above 100 degrees Celsius immediately explodes to 1,600 times its original volume, and it continues to expand as the temperature rises. The second thing you will remember is that there were no engineers before there were engines. Clever, maybe foolish men working in the dark science of exploding water were called philosophers. They were driven by the commercial opportunities to be found in exploding water. None of the brave philosophers who sought to control the power of the devil ever managed to do it. Many died as their vessels, sealed with boiling water, exploded. Because they had dealt with the devil, they were often buried in unconsecrated ground. High-pressure steam in a regular-shaped vessel will find the weakest spot, maybe a rivet, and burst the vessel with dire consequences. Watt was fearful and refused to have anything to do with pressures in excess of 1 bar or 14.7 psi absolute. Had he built the carriage he designed with its wooden boiler, it would have exploded. The Watt engines were built on terminal technology. A young Cornish mining engineer called Richard Trevithick wished to invent something that would replace the horse as a means of transport. Cornwall was a rich mining area. It supplied the world with copper and tin. It had the greatest number of Watt engines in one place in the world. Trevithick understood engines. Watt said Trevithick should be hanged for working in strong steam. But Trevithick was a single-minded, confident young man who gave a lot of thought to the power found in steam. He knew the dangers and he set out to overcome them. He did not improve the Watt engine. He developed completely new technology. No part of the Trevithick engine was interchangeable with a Watt engine. He started with a designer boiler that would contain high-pressure steam, the cylindrical pressure vessel we recognize today. The third thing you will remember is that cylindrical boilers have advantages over irregular shaped boilers. Trevithick realized that a vessel of uniform shape, made of a suitable material, will contain a uniform pressure. Trevithick boilers were cast in iron to create a uniform surface with one secure end plate. But Trevithick's new boilers presented problems not found in open boilers. The fire was not under a level surface, so heat was lost. As the steam was consumed, so the water level fell. A pressurized boiler cannot be opened to add more water. The discharged steam contained energy. This is heat, and it can scald by boiling bodily fluids. Trevithick set about solving these problems. Instead of putting the boiler in the fire, he put the fire inside the boiler. The fourth thing you will remember, Trevithick created the world's first shell and tube heat exchanger. To keep the fire compact inside the boiler, he fed the hot gases around 180-degree bend and up the chimney. Industrial units, known as Cornish boilers, had straight tubes. Some even had two. Trevithick designed a high-pressure pump to mechanically inject water into the boiler. He fed the exhaust steam safely up the chimney, where it emerged with the smoke, making a puffing noise. This had two effects. The blast effect up the chimney improved combustion as it drew air with oxygen through the furnace floor. The hot exhaust pipe to the chimney transferred waste heat to the water refilling the boiler by means of a concentric pipe, another shell and tube heat exchanger. Trevithick designed a four-way valve to achieve double action of the piston. That's power strokes up and down. And he fitted a safety valve. At last, the devil's invisible high-pressure steam was under control and it was doing work. It was the first effective steam engine. The fifth thing you will remember is that you have never seen steam and never will. It's invisible. What you see is water vapor. Like the clouds, it has little heat and no power. The original Trevithick high-pressure engine with water weighed about 4 tons. A Watt engine, with its necessary engine house, boiler and counterweights, could weigh 600 to 800 tons. The Trevithick engine was much cheaper. The Trevithick engine could be built in any size and located anywhere to power the Industrial Revolution. The Trevithick engine could be mounted on wheels and in ships to power the Transport Revolution. The steam engine had eventually arrived. Industrialists quickly saw its advantages and copied it. Some paid Trevithick royalties. Most did not. Trevithick was a very busy man who invented many things we take for granted today. His adventures took him to Southern and Central America. When he returned in 1827, the world was being powered by his engines. He received very little benefit. The largest steam engine in the United States is the Cornish engine at Iron Mountain Mine in Michigan. We built a replica of Trevithick's 1801 road locomotive.